I saw one of your articles about monolith, which I think is pretty interesting to maybe educate or clarify with a lot of people. So in that article, you basically title it "The monolithic architecture is not an anti-pattern." So while so many people these days think, okay, monolith is a bad architecture, we should move away from it, should adopt microservices. Why with this article saying that it's not an anti-pattern? Maybe you can enlighten us on this front.
Well, I mean, if you think about what a monolith is, it's a traditional architecture where everything gets packaged, as say in the Java world, as a single war file. So your architect, from a logical perspective, you've got modules, packages, and they're collaborating to handle requests, and you've got a single database. I mean, it could be a bit more complicated than that, but it's best think of it as a single database. That's really simple. All communication between the modules of your application are simply method or function calls. All of your data is in a single database, which means that you can just use regular ACID transactions. And there's just the application. So it's just simple and familiar. Whereas immediately you switch to the microservice architecture, you're building a distributed system. So communication between the different parts of your application and now some kind of inter-process communication, whether it's REST or gRPC or messaging and so on, which is just much more complicated than simply calling a method. And then your database. In a microservice architecture, one of the key essential characteristics of a service is that it's loosely coupled. There's a couple of different meanings there, but one of them is design time coupling, which is where you want to be able to change your service without other services having to change in lockstep. One key way to achieve that is to treat each service's database as private. So kind of like private fields of a class, right? No one can access that. So what does that mean? Well, it means that each service has its own database. So that makes transaction management much more complex. You can't simply begin a transaction, update arbitrary data in multiple services and commit that transaction. Well, you could use two-phase commit, but that's quite complex. And it also introduces another type of coupling, runtime coupling, which is where services have to be up together in order to handle a request. And that actually impacts your availability. So you can't use classic distributed transactions, and you have to use eventual consistency, which is much more complex. So it's like the monolithic world, simple. The microservice world can be more complex.
So hearing what you say about microservices and all this complexity, probably it's an exponential difficulty in terms of difficulty, right? Where you have to handle transactions, for example, eventual consistency. How about failures if you need to coordinate multiple services? So why suddenly all this craze about microservices? What do you think will be the right time for any company or for any product to actually embrace this?
Well, it's sort of, you assume that you're operating in a context where you need to deliver software rapidly, frequently, and reliably. You view the state of the art for software development practices. This might sound extreme, but the ideal world is where I'm a developer, I commit my change. That change is just automatically built, tested, and deployed into production. And as a developer, I'm committing changes at least once a day. So you've just got this constant stream of small changes, being built, tested, and automatically deployed into production. One of the challenges, so if you've got a small monolith, you can do that. There's many different factors to consider. But if you think about, well, how long does it take to run the tests? That's one key factor. If your monolith is small, the tests will execute very quickly. So your deployment pipeline can keep up with the rate of commits that are coming from your developers. As your application grows in size, it gets bigger and bigger, and then the tests take longer and longer. If you think about even just something as simple as the startup time for your application, a massive monolith can take many minutes to start up, and then you can run some tests. So ultimately, there are these issues around the size, just the pure size of your application slows down your deployment pipeline. And then also from the perspective of a developer, if I'm working with this complex code base, that can be overwhelming as well. And there are ways to modularize it so that you can break things up. You can have a modular monolith where you can break things up into vertical slices and which can be worked on independently. But ultimately, they have to be assembled together and tested. At some point, it becomes problematic. Plus, when you deploy the application, you're deploying it in its entirety, which I think is just inherently complex. And then you contrast that with the microservice architecture where you have a bunch of team-sized services. So I'm working on the order management team. I'm responsible for the order service. That's a much smaller, more easily understood code base. I can build it, test it quite quickly, push it into production. And I can change the order service without having to update customer management or account management and so on. So you have that independent deployability. And so it can be, if you've got a rapid rate of change, the microservice architecture is much faster, much more fluid. And then the last point I would make is, you think about modern application or successful applications that run a business, they tend to last for decades. So you imagine that you've got some 15-year-old application and it's massive. Upgrading that application to a new technology stack, even basic stuff like I want to apply security patches. So which means that you have to remain reasonably current. You want to hire people. They don't want to work on ancient technology. So it's important to keep your code base current in terms of what technology stacks it's using. That's really difficult if you have a massive monolithic application. Whereas if you contrast that with the microservice architecture, each service is relatively small. It can have its own specific technology stack, and you can upgrade one service at a time. And that helps you build these applications that are sustainable over the long run.